Okay, so this is the set theory homework. We'll start with question 16. I hope you can see the page well enough. Choosing a statement that describes A and B. Well, as you can see, B is completely contained within A, so that means that B is a subset of A. Looking across at these statements, A subset B means that A is inside B, B subset A, so this is the correct one. B is a subset of A. Looking at these two, you can see that A and B are completely separate. They have no intersection. So you're looking for a statement that says that there are no intersections. Obviously, clearly A is not in B and B is not in A. A union B equals the universal set. That means that basically if you take everything that's in A and as well as everything that's in B, that's the same as all that there is. So in other words, there's nothing outside A or B. Representing this would be kind of tricky because effectively you've got stuff which is A, stuff which is B, and stuff which is both. I'm not sure how you best represent that. Sorry, my mind's gone a bit blank, other than to say that this area doesn't exist. Yeah, I'm sure there's a good way of doing it. Anyway, sorry. A intersection B equals empty set. That's the one you want, because the intersection clearly doesn't have anything in it, so you'd say A intersection B equals empty set. Okay, moving on. The mathematical name for the quadrilaterals in A with two pairs of parallel sides is, of course, parallelogram. The next one caused people a lot of confusion. You have A intersection B, so they have two pairs of parallel sides, but they have a right angle. Now, in order to have a right angle, this side has to go this way, and this side has to go this way. But, of course, you have to have a side parallel to this one going in the same direction, and you have to have a side parallel to this one going in the same direction. The only way that's going to be achievable, if there are two pairs of parallel sides, is to have a rectangle. P intersection Q, multiples of 3 and 5 less than 11, that doesn't exist. So it's an empty set because P is 3, 6, 9 and Q is 5, 10. Is it true that 10 is in the union of P and Q? Well, union is anything which fits either of the rules. That's 10, by the way, not 1, 0. So yes, 10 is in Q and is therefore in P and Q. P union Q. On to the next page. A intersection B, again we're looking for the overlap, so it's 1 and 3, curly brackets. A union B is 1, 2, 3, 4 and 5. We don't repeat, and you try and put them in order. 3, the A means 3 is a member of set A. I mean, you'll probably get away with something slightly less than that, but you want to get as close to the right answer as possible. People found this question very difficult. R is a subset of P. That means that R is inside P. So there's R. Q intersection R is empty set. So that means that Q does not overlap with R, but we actually have to look at the next statement before we know where Q is. And this is the hardest one to decode. P union Q is the same as P. That is to say, everything which is in P or in Q or both is the same as everything which is in P. It may not be obvious, but what that means is that everything that's in Q must also be in P, because P covers everything that's in either P or Q, if that makes sense. It's quite a difficult concept. Anyway, we know Q is inside P from this statement. This is basically saying Q is a subset of P. And because Q is a subset of P, and Q has no overlap with R, Q is another circle inside P, like this. Quite tricky, that question. Okay, now we've got a universal set which is all whole numbers, and A is multiples of 5 and B is multiples of 3. It says shade the region that says A intersection B complement. So we're looking for something that fits both rules. It must be inside B, and it must be outside the circle of, inside A, but outside the circle of B. So that's this bit here. 3 members of A intersection B complements are things which are multiples of 3, but are not multiples of 5. So that would cover things like 3, 6, and 9, but obviously not 15. C is multiples of 10. Now, all multiples of 10 are also multiples of 5, and some of them are multiples of 3. That's quite confusing. We know that C has to be inside B, but there also has to be some things which are in A and some which are not. So C ends up being over here. 3 members of the set A, so that's multiples of 3. B, multiples of 5, but C, not multiples of 10. So we're looking for multiples of 3 and 5. This is FizzBuzz, 15. Not the next multiple of 15, which would be 30, because that is a multiple of 10, so 45. Not the next one, because that's 60, so the one after that is 75. So multiples of 15, which aren't also multiples of 10. Another tricky question. Here we go, everyone's favourite. 35 students in the group, 18 play hockey, and then the rest adds up to more than 35, and it's really confusing how it all adds together. So we know the total is 35. 18 play hockey, that's the total of this bit and this bit. 12 play both hockey and tennis, so that makes our life easier. So 12 goes here. And wait, if 12 play both hockey and tennis and 18 play hockey altogether, that means that the remaining 6 just play hockey. I hope that makes sense to you by now. 15 play neither hockey nor tennis, so they go outside. And we know that this region plus this region plus this region plus this region adds up to 35. So we can say 6 plus 12 plus, in this case, x is here, plus 15 equals 35. And because this adds to 33, that x is 2. That's not the answer, though, because it asks for the people who play tennis, not the people who only play tennis. So having put 2 in here, we need to add together the 12 who play hockey and tennis to the 2 who play just tennis, which makes our final answer 14. P complement. So P complement is all the things which are not in P. We have to look at the universal set and look at the things which are missing. The things which are not 2, 3, 5, 7 are 1, 4, 6, 8, squiggly brackets. Q is a subset of P, and then there are 3 things in Q. So Q is completely contained within P and made up of 3 things. So it's any 3 out of 2, 3, 5, 7. So the answer 2, 3, 5 would work. The answer 2, 3, 7 would work. The answer 3, 5, 7 would work. Any of those are correct. Here we go. Number of things in P. Hopefully everyone knows by now that number of things in P covers all the things in P, so it's 5 and 3, so it's 8. Number of things which are not in Q are the things outside the circle of Q, so that's this one and this one, 12. P intersection Q complement. Now, with intersection, it has to comply with all the rules, so it has to be something which is in P, which is in Q, and which isn't in Q. Now, hopefully, you'll realise that things can't be Q and not Q at the same time. So the answer to that is 0. Irrespective of whether that P is there, Q intersection not Q has to be 0. And then P complement union Q complement, this is the one that's most confusing. So it's easiest to understand this by shading. We can count everything that's outside the circle of P. And then we can count everything that's outside the circle of Q. What we've shaded, oops, sorry, I'm shading into Q. What we've shaded in effect, and it's not obvious from my diagram, is everything apart from the thing in the middle. The way that we could make that obvious, if you find union confusing, is to do the opposite of this. So the opposite of P complement is P. The opposite of union is intersection. The opposite of Q complement is Q. So effectively, the opposite of this group is P intersection Q. We're doing everything apart from the bit in the middle, 3, so it's 7, 5, and 4, and the answer is 16. Last question. Another fun one. So, we need to read these instructions very carefully. We know that 10 play hockey only, that number 10 is on there. It says 9 play football only, so that 9 can go here. 13 play tennis only, so this makes our life easier. When it says only, these are the exclusive groups that are just in these areas. It says 6 play hockey and football, but not tennis, so that's this bit here. Then we need to be careful. It says 7 play hockey and tennis. Now, hockey and tennis is the overlap of hockey and tennis. It's these 2 regions. We already have x here, so if the total is 7, then the remainder is 7, take away the x we've already accounted for. Similarly, when it says 8 play football and tennis, that's the overlap between football and tennis, which is these 2 regions. We've already got the people who play all 3, so the people who play football and tennis but not hockey is the 8 minus x. Now, we're told that everyone plays at least one of these groups. There's nothing outside, which means that all of these have to add together to the total, which is 50. Sorry, I'm jumping ahead to the last question. First thing it asks for is the people who play hockey and tennis but not football, which we've got as 7 minus x. We add all this together and make it equal to 50 to find x. So that's 10 plus 7 minus x plus 13 plus 6 plus x plus 8 minus x plus 9. That looks a bit confusing. That's all equal to 50. But there are ways in which we can simplify that. If we just add together the numbers, we get 10, 7, 13, that's 30. Add 6 is 36, add 8 is 44, add 9 is 53. And then if you look at the x's, we've got minus x, minus x. Well, clearly a minus x and a plus x will cancel, and we're just left with minus x. And if 53 minus x is 50, then x is 3.